Hey Dragons, this lesson is on direct variation. There are 4 things that I want you to remember about direct variation. I want you to put these in your notes, whether this is your composition book or your notebook or wherever you keep notes. I want you to copy down what you see at the beginning of this video. Pause it if you need to, but just make sure of these 4 things. If you know these 4 things about direct variation, you're going to be in great shape. All right, first thing, direct variation is a linear graph. It's really y equals mx plus b as it always been, except there is one change, and that change is b is always going to be 0. So my y-intercept in every direct variation is going to be 0. So in reality, your y equals mx plus b becomes y equals mx plus 0. And you don't need to say plus 0 to anything. So really, it's going to be y equal your slope times your x. Your output is going to be your rate of change times your input. Okay, so if you're able to solve an equation and you get y by itself, and then you have the slope times the x variable, and then there's nothing left, it's a direct variation. If you do have a y-intercept that is something other than 0, it's going to not be a direct variation, it's just going to be a line. So for example, y equals 5x would be a direct variation. I'm just going to say dv for short, because my y-intercept is 0. Y equals 3x plus 1 will not be a direct variation because its y-intercept is not 0. That's the first thing I want you to remember. Alright, the second thing I want you to remember about direct variation is that the math gurus, whoever they are, decided that, well, direct variation is something special. It has a y-intercept of 0. So they took the slope and they gave it an alternative name. And they used a different letter, k, and k is called the constant of variation. Alright, you got to remember that. K is the constant of variation, because if they reference that, what I want you to think, that's the slope. Okay? So, in a direct variation, you're going to see the equation y equals kx. K is the constant of variation, but it acts the same way as a slope. It's still a rise over run. It's still a ratio. Alright? So there's nothing different except they gave it a new letter, but it means the same thing. Now, if you solve this for k, if I divide both sides by k, the constant of variation is simply going to be your output over your input. All right? This is something very important to remember, because if they say, hey, what's the constant of variation? You give me an ordered pair, I'm going to put the y value on top, I'm going to put the x value on bottom, and I'm going to simplify it and say, there you go, that's my constant of variation. So this is actually a rise over run. This is a change in y over change in x. The only difference is that we're going through the origin. We don't have to do any subtraction. It's just plain old y over plain old x, and that's going to give you your constant of variation. All right? Third thing I want you to remember, third thing I want you to put in your notes. If you see a graph of a direct variation, it always goes through the origin. That kind of ties in with the first one. So if I come over here and give you this picture right here, you can see, or hopefully you can see, that this that I've made up is simply going to go through the origin. Here's my x-axis, and here's my y-axis, and hopefully it's very obvious that I go through the origin, and it does. This is just one direct variation. There are a whole bunch more, but if the line goes through the origin, it is a direct variation. It's a dead giveaway every time. Now, here's an example. Do you think this one is a direct variation? Oh, of course not. The origin's right here. Here's my x-axis. Here's my y-axis. If you notice the origin right here, this line does not go through the origin 0, 0. So if a line doesn't go through the origin, it's not a direct variation. Okay? And if it's not a direct variation, you can't find the constant of variation. You only have a constant of variation if you have a direct variation. Okay? Now, last thing that I want you to know is that the ordered pairs of a direct variation are proportional. Hopefully you remember proportions from middle school. All right, let's go back to our example. Okay? Excluding the origin, because we're not going to use 0, 0 in our proportion. Okay? You can pick any two ordered pairs on a direct variation, and the x and the y's are proportional. So if I pick this point right here, -6, -9, and make that into a ratio, -6/9, and then I pick any other one on the line. I just randomly pick this one, 2, 3. I put 2/3. So do x over y and x over y. Are these equal? Well, you remember how you check proportions? You check the cross products. So if I take a -9 and multiply it by 2, what do I get? I get -18. What's the other way? I cross multiply this way. I get -6 times 3. Well, what's that? Oh my goodness, it's -18. These two things are equal. So are these proportional? Yes, they are. You can cross out the question mark. They are proportional. And these only work, you can only do this on a direct variation. That's what kind of makes it special. Okay? Well, what about some other pairs? Pick two others. 4/6 and 8/12. Alright? If you take a look at this, put that in your calculator and reduce it, and well, you should know how to do that without a calculator. That's 2/3. What does 8/12 reduce to? Oh my goodness, it's 2/3 as well. So this one is proportional as well. So, the ordered pairs of a direct variation, any two that you pick, of a line that goes through the origin, you can make a proportion that is true. Now, I just want to show you, go back to my other example where it's not a direct variation. Remember, this one is not. Do you remember why? That's right. It doesn't go through the origin. It doesn't go through the origin. Now, look, if I pick 2 points here, I pick this 1, 5, and I pick the 4, 8. X over y, 1/5, 4/8, x over y. If I cross multiply these, I get 5 times 4. What's that? That's 20. And if I cross multiply the other way, I get 1 times 8, which is 8. Now you tell me, is 8 equal to 20? No. It's not proportional. And it doesn't work because it does not go through the origin. Pick another one. -1 and -5. If I cross multiply this way, I get 3. Cross multiply this way, I get -5. 3 is not equal to -5. Okay, so if you haven't gone back and copied these 4 points into your notes, I want you to pause the video and go ahead and do that. Once you have that, go ahead and unpause the video, grab your worksheet, and we're going to do some of these together, and I'm going to try to reference some of the problems. I'm going to go ahead and break this video up into smaller chunks. So I'm going to stop this one. Once you are finished with everything on this video, go to the video that says Direct Variation Part 2.